Hello, math mavens. We are going to be talking about some hypothesis testing for both means and proportions today. As you can see, I've got the hypothesis testing notes document on the left, and on the right, I have the data going with it. This is from Accounting Professionals. So this is 74 members of an Institute of Management Accountants, also known as the IMA. And we've got the following variables about them. As you look through, you'll notice that some of them with the little t's are in particular going to be categorical variables, and then the rest appear to be quantitative. One thing to be very careful about is age group, since it is grouped and you're given a range of values to select from, is categorical because you have categories, also known as qualitative because we have groups or categories. This is something to be careful about. If you want to use age as a quantitative variable, you can't give it a multi-select button where there's a range of values, because if you do that, it immediately becomes groups and therefore is qualitative instead of quantitative. Anyway, so the quantitative variables here are going to be years of service and undergraduate study. Years of undergraduate study. The rest are going to be categorical. Now, employee is just an ID number to identify them different from each other. This is like not even useful, but if you were to sample from this, it would be useful just to track where it came from in your original data. All right, so starting off, you suspect the average age of accountants is the average professional accountant has at least a bachelor's degree or higher. So you see at least, so greater than or higher. So one thing to keep in mind about this is it's describing a ho here, not a ha, a null hypothesis, not an alternative. And I know that because it's talking about at least that or higher. So it should be a bachelor's degree or higher. So we don't have bachelor's degree or higher on here. We have years of study. But to get a bachelor's degree, traditionally you need 4 or more years of education. So we're going to do 4 or more. So I'm going to say, I'm just going to use the mean symbol. So to get the mean symbol on Word, it's kind of hard. You got to go to Insert, Symbols, and then find the mean button. There you go. And I'm going to use that again to do my greater than or equal to. So greater than or equal to 4 years. All right. Yeah, because it's years of education or years of study beyond high school. So, all right. And then for my ho, then I'm going to do my average is less than 4 years. You'll notice I include my units with my ho's and my ha's. I do this because it helps me double check to make sure it has units. If it doesn't have units, you're dealing with a proportion. So if you're suspecting you're going to be using means, just watch yourself out. That's a good way to avoid that. So I'm going to calculate the p-value and or test statistic now. So since I'm dealing with quantitative data and I do not know the standard deviation of the population, I am going to have to use a t-test. So we're going to go to Stat, Basic Statistics, down to a 1 sample t. Now this will feel a lot like last week when we were doing, last lesson, not last week, where we were doing confidence intervals. But you may have noticed we didn't touch this little box down here that says perform a hypothesis test. Oops, I don't have summarized data. My sample's in a column. Sorry about that. However, if you had a summary like, oh, this is what my sample looks like, it has mean this and standard deviation this is what you would choose. So we have summarized data. So we want years of undergraduate study. I want to perform a hypothesis test. It asks you what you want to use as your mean for the hypothesis test. That comes from the ho. It's 4 years. A Minitab does form the ho a little bit differently than what you might expect, so we'll get into that a little too. Let's click our options. All right. And now, since I'm doing a hypothesis test and I check this box, I really don't care what confidence level it is. That has nothing to do with what the test is going to do. What you need to focus on is the alternative hypothesis. So I need to make this a less than. That way it matches my alternative hypothesis right here. And if you always write these the same way I do with variable, value, and inequality in between, this will always match what your values are that you set up for your part A. Let's hit OK. And OK again. And everything's okay. So since I'm not doing a confidence interval, I really don't care about this descriptive statistics box. I care about the test box. So you'll notice the null hypothesis Minitab uses an equal to, because without an equal to, you cannot make a a distribution to perform the test on. So there's that. What you need to focus on is, does the alternative match what I want? Because that's more important. That's what builds your p-value. Speaking of p-values, this looks like it's 0. Now don't make the mistake of thinking this is 0. It's just so small that when we round, it looks like 0. So if you right-click on that, you can get more decimal places for it. Oh, it's got to go out to 6, huh? Yep. See, there is a value out there. It's just so small. It looks like nothing. So I'm going to go ahead and copy my test box, even though I really only need the t and the p-value to do this. Oh, and it always wants to number it. That drives me crazy. So again, I don't need this part. I just need these two because I already have my correct null and alternative hypothesis. And Minitab, because it was written by the Brits, does them slightly different. I'm just going to delete those rows because I don't need them. There, that looks nicer. All right, focusing on my p-value. So what I'm going to do next in part C is I'm going to do both ways you can make your decision. So you do not have to do both ways. I'm going to do both so that you can see what they look like. And again, you know, if you're somebody who really enjoys the p-value approach, bam, this is for you. If you're somebody who really enjoys the critical value approach, this is for you. So I'm going to start doing the p-value approach just because it's one I can do a little bit faster. I have to do a little more work to do the critical value approach. And I'll mix and match as I go through this video. So starting up here, my alpha is 0.05. My p-value is much smaller than that. So that's going to be an indicator that I'm going to reject the hoe. I have a small p in this case. So since my p-value, of 0. Tons of zeros. 3, is that enough of them? 1, 2, 3, 4, 5. I think it's good. Is less than the level of significance. I just don't want to type alpha. We will reject HO, the null hypothesis. All right, so that's how you do it with the p-value approach. You compare the p-value to the value of alpha. They're both probabilities. If the p-value is smaller, that means you have an unusual sample. It's evidence against your null hypothesis. You'll reject the null hypothesis. Now, with the t-value, we're going to be doing the critical value approach. So, here's how you can do this again. So I need to compare this to a t that has the same level of significance on my distribution. So I need a critical value to compare this to. So to do that, we're going to go to Graph, Probability Distribution Plot, over to View Probability. That's the only one we ever use. Now I'm not dealing with the normal distribution. I'm actually dealing with t here. And I got to be careful. So earlier in the data, it described that there are 74 members in this random sample. So I know that my sample size, my n, is 74, which means my degrees of freedom is one less than that, or 73. All right, now I need to go over to shaded area. So here's where you got to be careful. I want to put my alpha value as my probability, which is 5%. So these currently match. That's good. And then my ha tells me which direction I need to go. So since it's a less than, I want to create a left tail. If it was a greater than, I'd be creating a right tail. If it was not equal to, I would be taking a both tail. And it's always just alpha in here, which is pretty easy. Snazzy. Okay, so the critical value is negative 1.666. That's a little creepy. So in particular, since my t value, my test statistic of negative 4.9, is way out here somewhere, like it probably isn't even on this because that's 1.5 away and it's like almost 5. It's way out in the tail. It falls in my rejection region. This tells me that I would be rejecting the null hypothesis. So if it falls in the red region somewhere, that's when you reject. If it falls in the white somewhere, that's when you fail to reject. So since the critical value is and the test statistic, can't type today, of negative 4.90 is less than, I avoid it because it's very unclear, the critical value. We will reject the null hypothesis. All right, so since we're rejecting, now we need to carefully state what that tells us. So keep in mind, remember what this is about when you're trying to describe your description. You've rejected the hoe. It looks like your evidence, your sample evidence seems to support the ha, which says, hey, it looks like it's the average level of education is less than 4 years. So that's what we're going to write. So there is sufficient evidence. Evidence. I'm having a hard time today. To conclude that for all IMA. Now be careful here. I'm talking about my sample and population here. So when I say all IMA accountants, That's who my sample represents. So since this is a sample from the IMA accountants, this sample represents a population of all IMA accountants. And remember, when you're concluding a hypothesis test, it's about the entire population, not the sample. So all IMA accountants have a average level of education less than 4 years. 4 years, that would have been funny. Or below a typical bachelor's degree. Do I need to capitalize degree? I know I need to capitalize bachelor's. These are the things I wonder about at night. Yeah. You guys don't care. I've been told my laughing's really loud, so I'm trying to not laugh so much. I'm having a good time in my office by myself right now. Okay, we're going to take a slight pause for me to blow my nose. When I come back, I will be doing number 2, so if you haven't read number 2, now's a great time to do so. Okay, so let's start off. So we're looking at some labor statistics this time. So this is from the U.S. Bureau of Labor and Statistics, which is from a census. So that's telling me I'm talking about my population here. A typical accountant stays the same job for more than 10 years with a standard deviation of 1 year. So this with a standard deviation is very important. This is telling us that we know the population standard deviation since it came from a census. That's going to tell me that I'm going to be doing a z-test this time instead of a t-test. So there's a little subtle hint in there. And more than 10 years, since it's not, an equal to, that's going to be describing my ha, not my ho. So more than is just a greater than, so that's that guy. Now I'm going to do this one a little bit differently just to give you some variety. So I'm going to say mean years of service, since that's the variable that describes my how long they've been at the job. And I like mean years of service because it's like mean of years of service. That's a little bit better. I kind of like this better than just writing a mu because it's more specific about what you're doing the mean of. If you like that, feel free to use it. If you don't, well, you can go and do them the other way and just put a mu in there. And so for my ha, it needs to account for the rest of it, so it's got to be a less than or equal to. I'm a little scared about this one because there's some big values in years of service. So I don't know if this one's going to come out being a reject the ho. I'm thinking maybe, I don't know. I guess we're going to find out. Let's perform the test. So like I said, since I know the standard deviation, this is going to be a z. Let's go to stat, basic statistics. Oops, my mouse flipped. One sample z, and then my samples in the column, it's years of service. My known standard deviation is 1 year. I'm going to perform a hypothesis test. My hypothesized mean is that 10 years of service. Alrighty, so just in case it's unclear, there's my sample. I'm going to test it saying this is my known mean and my known standard deviation, and then I'm going to hit my options and tell it I think it's going to be bigger. I have a feeling my ha is going to be correct on this one. Let's see if it's bigger, if it's significantly larger than what the Bureau of Labor Statistics seems to say. Because the other thing is, I got this from the last census, which I believe is almost 7 years ago now, because they're due to deal one in 2020. So it's old data, and this is newer than that. So I suspect that this is going to come out different. Oh, it's so different. Oh my God, look at that Z value. It's enormous. Whew, this is like a smack in the face. That is like the biggest critical value I've seen in a long time. You guys don't understand why I'm excited. Oh boy, is this going to be a rejected ho. It's definitely more than 10 years. Let's go ahead and copy that and paste it into our results. And again, it always wants to number it, and I will never understand that. And again, I don't need these 2 rows, so I'm just going to delete them because that's who I am, and I like my stuff nice and orderly. And Word likes to fight me on that. What is Word even? It's a test of your patience. That's what it is. Ay, ay, ay. It always wants to change B and C to A and B too, because that wants to number that. What the heck, Word? Anyway, so let's make our decision rule. I'm going to start with a p-value. So I didn't copy like as many decimal places for this one because like you can go all the way out to 16. It's not going to work. I know that by looking at my ginormous z value. This is saying my critical value is so far in the tail that it's 40 standard deviations away from the mean. This is going to be a definite rejection situation. But let's go ahead and describe that specifically and with evidence of why we're making it so that we get a really good conclusion written. So here we go. We're going to start with the p-value approach just like I did last time. So Oh gosh, I hit too many buttons and all these things happened. There we go. Hence the p-value is less than the, let's just put 0.05, the alpha value. Let's be specific, of 0.00, so small, can't tell, is much less than, that. Who writes this? I do. 0.05, we will reject the null hypothesis. So since my p is small, I have a sample that just really shouldn't happen if the hoe were the truth, so we will reject the hoe. Alrighty, let's go ahead and do our test statistic. So since I'm doing z here, I'm going to have to do a normal one. So we're going to go to graph, probability distribution plot, view probability, hit OK. I need to change this to a normal. Where is it? There it is. So we want mean 0, standard deviation 1, because that's our standard normal distribution. We're going to go over to shaded area, and then since I'm at greater than, we're going to be writing a right tail, and 5% because that's my alpha. I know I'm doing this kind of fast because, well, that's how it's done. So, hey, standard normal, because this is z, I want greater than, which gives me a right tail, and then alpha being 5% puts 5% in that tail. This is going to be like, yep, 1.645. So since my z value, the critical value, is 1.645, and the test statistic of 40 40 is greater than 1.645. Oops, my finger slipped. Reject HO. So when you're doing this, if you just want to ask yourself, does it fall in the red? Ah, it's in the red. I shouldn't yell. That's when I'm going to be rejecting. So this is so far out in the red, it's like on my other screen that you can't even see. So like my mouse goes off the screen. Like if this were where, oh, I can't move this around that much. Oh well, that's unfortunate. So that's like 2, almost. Well, 1.5. And we need to go out to 40. So it's like, I don't know. It's against the wall in your room, wherever you are, far away from me. It's so rejectable. All right. So since we rejected our null hypothesis, we want to say something along the lines of supporting the alternative. And they wanted to know more than 10 years of service. Absolutely. There's evidence to support that. There is sufficient evidence to support that the average IMA accountant has more than 10 years of service on average. I put my average in the wrong spot. So I said it says average here. I should say all IMA accountants have more than 10 years of service on average. Okay, I like that better. Sometimes you got to wordsmith these a little bit because it's got to say the average is on the 10 years, not the IMA accountants. And you need to say what you're supporting and where you're getting, is your evidence enough? This one's like so much evidence, it's not, it's like, no. Yeah, sorry. All right, so, oh yeah, I remember where I got this from. I'd never heard of catalyst.org before, but they're an interesting place to get some statistics, so maybe check them out. They're a little politically scary though, so just keep that in mind. But they have some good stats. Actually, you know what? I should be very suspicious of their stats based on their politics. You know what? Ignore me. Don't look at them. I just needed some place that described something about female accountants, and that was the first place I found. So judge me. Okay, so we know that about 53% of all accountants are female. Let's use this sample to perform a test on this claim. So we've got gender. That's going to be the variable I'm interested in. So I'm going to do proportion equal to 0.53. Or wait, do we think it's more than that? Test this claim. Oh, yeah, we don't have anything about more or less, so it's just going to be equal to. Remember, the not equal to is your default when you're not sure what to do, or it's not anything about I think this group is greater or that group is greater. Now, one thing to be concerned about is when you perform a hypothesis test on Minitab 18, you cannot tell it if you want it to count the women or the men, so we're going to be very careful with this when we're performing our test. So let's go up to stat, basic statistics, one proportion. So it's the one proportion test that we used to do confidence intervals last time, but here we're going to be using it to perform a hypothesis test, so we want to check that box. I want to put my sample in there, so I'm going to throw gender in there. And my hypothesized proportion is 53%. I'm going to check my options. Here's where you got to be careful. We want not equal to, and we are using normal approximation method, not the exact method. They are slightly different. Once yours looks like this, you're good to go. So again, double check your alternative hypothesis. Make sure you're on the right method. Make sure you've checked the box to do a hypothesis test, or else it will not produce that text box, the test box that tells you the result of your test with your critical value and your p-value. Okay, here's where we're in trouble. All right, so notice up here, event equals M. It's counting the men, not the women. So by process of elimination, we're going to say that if women is 53%, then we are going to be looking at 47% male. We're going to make a little note to ourselves about this too, because the only thing available in ours is male and female. Not that that's the truth. So need to test male for Minitab. So actually, you know what? Here, let's make this a little bit better. Proportion of males. So just to make it clear why I'm doing males instead of females, even though my claim is about females. The confidence interval here and the, well, I don't need that, but the hypothesis here is doing the proportion counting, proportion where gender equals male. So they're counting the males over the females, which means that when I go to do this, I'm going to have to do male. Now, one way you could fix this is you could recode this column with yes as female and no as male, and it knows to grab the yes. Or you can do what I'm going to do. I'm just going to redo the test using the proportion for males instead. So I don't want to use 53, I'm going to use 47. So I'm going to hit edit the last dialog and fix this and change it to 47. And then I'll get my right p-value. Oh, that's huge. Okay, that's what I thought would happen. Let's go ahead and copy and paste that into our document. And again, it's going to number it. I hate this. I wish I could stop it. If I had good editing software, I'd be able to do this faster. So be thinking about what this means while I waste your time making the document look pretty. Okay, so, huge p-value. Ginormous. Big P means I'm not going to reject the hoe. So, since the p-value of 0.776 is much, much greater than 0.05, it is not significant evidence against our null hypothesis. We are going to fail to reject. So just to talk to you a little bit about what's happening here is, remember the p-value is your probability of getting the sample or something worse, according to the idea of what worse might be, or more extreme, which means towards the tails. So as you look at this, this means that I got a sample that was incredibly likely. It happens about 77.6% of the time if the hoe were true. So this seems to support the hoe being truthful or being what's going on. So I ain't going to reject it. My sample seems to happen pretty commonly, therefore it's not evidence against the null hypothesis. Now we need to do our test statistic. So I have to be careful here. Whenever you're doing proportions, it's always a z, so I want the standard normal distribution. So we're going to go to graph, probability distribution plot, view probability. We're still on the, oh my gosh, that was loud. Standard, I have it not recording my sound on here, thank goodness, because that was very loud. Shaded area. All right. Here's where we got to be careful. So not equal to means two tails, and then alpha is 5%. Oh, I only used 5% for this whole thing. That's a huge mistake. Yikes. My bad. Let's hit OK. So it looks like 1.96 is my cutoff. So if I'm below negative 1.96 or above 1.96, that would be rejection area, but I don't have that. My value is between the two. So critical values are below, are not below, and 1.96 since the test statistic, yay, word knowing I suck, 0.28 is between them. Test stat is not in a rejection region. Why can't I spell this today? So we failed to reject HO. All right, everything it's saying looks like my hoe is the truth. So that tells me my proportion of males is 40%, 47%, or rather my proportion of female accountants is 53%, just like that data told us. So maybe I should trust that website. It's not as bad as I thought it might be. Oh, politics are not my forte. That's why I teach math. All right, so here we go. Let's talk about these female accountants. So there is sufficient. Okay, so you have to be careful here. I could say that my evidence supports my hoe, which would be I have enough evidence to say yes, it is 43%, or you could say there is insufficient evidence to say it's not 43%. So that feels more like, or sorry, 53%. That feels more like what we're seeing here. So I'm going to do a double negative on this sucker. Your English teachers would hate me right now. So I don't have enough evidence to say it's not the hoe. I'm failing to reject the hoe is how I'm going to phrase this. So there's insufficient evidence to suggest, to support the claim. I like that better. That the proportion of female accountants is not 53%. So see the double negative in here? It's not the alternative. So I'm saying it's not the ha. I should say all IMA, because that's who this is actually about. I like that better. All right. Here we go. Oh, that was fun. Oh, I remember this one. Yeah. Okay. So this one's going to be a little harder. In most large organizations, the age group 26 to 20, that should be the other way around, 20 to 26, make up about 30% of all employees. Or should have been 26 to 30. It's 26 to 30. I have a typo in this. I will have to post a new document. That sucks. Make up about 30% of all employees. You suspect in management accounting. In management accounting. Oh, yeah, the IMA people. This proportion is actually smaller. Ooh. Use the sample proportion to form a hypothesis test on this claim. So, a couple problems with this. I have to cough. Sorry, I forgot to hit record and type my ho and my ha. So, I'm back and I have things. Anyway, so, proportion. They want to see, is it actually smaller? So they want to know, is it less than 30%? And so this one's got to be greater than or equal to. It's got to make up the difference, and that is not the correct thing to type. Oh, I'm having a good day. How y'all doing? I can't tell. Feel free to leave your thoughts in the comments. So looking at age group, I'm going to try to do this test, but I know it's not going to work, because watch what it's going to do. So I'm going to go to graph. Oops. Stat. Let's pretend I know what I'm doing. Proportion. I'm joking about that. I do know what I'm doing. It's just sometimes I slip. Age group. Throw 30% in there, and you're going to get an error doing this, so I probably shouldn't check my options and make sure this is set right, because it doesn't even matter. I know it's going to tell me it's wrong. Let's do less than. I just want to teach you how to deal with the error this is going to give me. So I threw an age group. I said, hey, we want smaller than. It matches my ha, and 30% is my proportion. Let's hit OK, and OK again. And column contains more than 2 distinct values. That's because if you look at age group, there's a bunch of stuff in here that's not 2 things. So watch. If you go to stat, tables, tally individuals, and throw age group in there, you'll see that, oh, I actually have like 6 groups it looks like here. Yikes. So that's the problem here. Remember with the proportion test, it can only do a success out of a total, so it needs things that look like gender, where there's just 2. Recode to text. I want to recode age group. I'm going to do individual values. So that's not what I want. That is what I want. Not what I want. Not what I want. Not what I want. Not what I want. And not what I want. We've done stuff like this before, so I've coded everything as a no except for my yes. I'm just double checking by clicking in here that everything kind of looks the same. And hopefully it is. So be careful if you get that error again. One of your no's has a space or something in it that you can't see, and that means that you need to do your recode again. So let's hit OK. There's my recoded age group. Now I should be able to perform my test. let's go back to stat. Basic statistics, one proportion. Let's throw our recode in there now that we've fixed this into something you can do a proportion test on. So it's got a defined success and failure. Let's hit OK. And it is counting yes like it's supposed to, which is good. So its event that it's recording is yes. All right, and we get our P and our Z value. Ooh, those are questionable. Those are kind of close to maybe being something. Let's find out. Let's copy and paste it over to B. Let's see if I can paste this without any numbering. Yeah, let's just keep text, because I'm tired of fixing the numbering. I'm lazy. So there's my answers to B. Let's make it red. All right, now we need to make some decisions. Okay, so I actually need to see my ho and ha to do this next part. So first up, let's start with our p-value. So, oops, let's make it big so you can read it easier when you're looking at this on YouTube. So the p-value is bigger than 5%. So we consider this a big P, which is not good evidence against our null hypothesis. So we're going to fail to reject HO. And now to look at the Z value, I need to come up with the critical value. So I need to go to graph, probability distribution plot, view probability. All right, and here's where I got to be careful. Standard normal because I'm on Z. And then let's see, alpha is 5%, but my ha is a less than. So this needs to be in the left tail, the lower tail, as it's doing the stuff to the left towards the less tail as your more extreme values. And that gives me a cutoff of negative 1.6.5. Okay. So critical value is negative 1.645. I did it again. I keep hitting 5.4 instead of 4.5. Oh, and then we see that our Z value is not less than that, so it would fall in the white area, which means we would fail to reject. So since the test stat is not less than negative 1.645. Just in case it's unclear, I'm going to write in parentheses what the 10th statistic is right here for people who are still not sure that it's just a Z value or a T value. It's whatever you get from here. Is not less than 1.645. We fail to reject HO. So, aha. So it looks like that age group in particular for the IMA accountants is not smaller than 30%. Yeah, we're going to write that now. The evidence, there is insufficient evidence to support for IMA accountants. I'm going to throw all in there again because I want to make sure I'm clear that this is a population. The age group 26 to 30 is 30% of the employees. Ooh, I got to be careful here. So I said is 30%, so that's not true. What I wanted to do was is less than. Yep. Because is sounds like equal to. So not enough evidence to say it's less than 30%. That's what we were testing. Is it smaller than 30%? That was our ha. So I can't say it's the ha because I can't reject the ho. Good times. So another way you could have done this if you were worried about my whole like recode job is if you go back to the table right here. So I want to leave my test statistic up here so you can see this comes out the same. And you looked at this and you're like, okay, 26 to 30, that's 17 out of, wait, I'm on the wrong one. 26 to 30, that's 17 out of 74 of them. So what I could do is go to stat, basic statistics, one proportion, and instead of doing recoded age group as my variable, I could have just gone to summarize data and said, oh, well, there's 17 of them out of 74. Let's just do that instead. This is going to come out exactly the same as what you're going to see. So now if I hit OK, oh, hey, look, it's the same Z and T value if you would have done it using the sample. So if you are feeling uncomfortable with recoding, you can just use tables like I did right here to count it and do it that way instead. So just physically counting them out of the total. I would suggest if you're planning on doing that or thinking about trying it, use the tally to do the counting for you. Don't count it by hand. You might mess up and end up with like 18 out of 74, like you saw a group that you thought was not, that kind of jazz. All right, well, that's it for today. Hope this helps you practice your hypothesis tests on Minitab.